In this video, we're going to try to prove that x squared minus square root of x plus 2 has a solution on this interval 1, 2. Okay, there are many ways to do this problem, but for us, we're going to try to find the simplest one, the simplest case that we can. One key idea to get a picture of what's going on is to make some graphing. Okay, so here we can we know the x squared is something like this, okay, approximatively. And if say this is -1, this is 1, this is -2, and 1x is 0, it's going to be 1, 4. So here, okay, these values are very important. So we are asked to find a solution on this interval 1, 2. We see that we have a solution. That means a common point on the graphs. So on a common point. So this is like 1.4, maybe 1.4, 1.5. I don't know exactly, but it looks from the graph that this is the point that we need here. Okay? That's because this is the intersection of two graphs. So this is the square root graph, and so this is x squared, and this is the square root plus square root of x plus 2. So the idea that we have is that we see clearly that we have this point here, okay, where the two graphs meet, is that's a solution. We wanted that solution for between 1 and 2. We also have this point, okay, but since we are only interested in this one, we're gonna see what we mean. If we want to graph the function, so here I use the fact that I'm looking for x squared minus square root of x plus 2 is 0, and I said these two graphs equal, okay, these two. So this is x squared, and this is square root of x plus 2. I can also consider this one as one simple graph, okay? So if you want to do that between 1, let's say, and 2, I'm gonna get something like this. Sorry here. So this is 1, this is 2, okay? So the graph is gonna hit the x-axis on this point. That's close to 1.4, 1.5 exactly, I don't know. So our aim is to prove that there is a solution for this equation, okay? I tried to do it graphically to get you an idea of what's going on, okay? So to prove it, or to do it without any graph or any calculators, we just assume that we have a function f of x that's defined by x squared minus square root of x plus 2, and that's defined on 1, 2, okay? So we're going to use the intermediate value theorem, okay? So that's one key. So we have f of 1. So f of 1 is 1 minus square root of 3. It's something here. So f of 1 is negative, okay? So this is this value. And f of 2 is 4 minus 2, that's 2, okay? So that's 2. So let's say this is 2, that's here, okay? So the intermediate value theorem says if there is a certain n in this interval, f of 1, which is here, and f of 2, which is here, that means there is some n here in this interval, then there is a c in there is some c in this interval 1, 2, such that f of c is n, okay? But since we want to adjust the 0, so we're gonna keep looking here on the y-axis between f of 1 and f of 2 until we find the one that gives us 0, and it's this one here. So there is this here, this 0, that let us have this one. They call it alpha. So there is alpha or c 0. Okay, so 0 is between in this interval. Therefore, according to the intermediate value theorem, there is some alpha in this interval 1, 2. That's a solution. That make this one 0. Okay, how to prove that the alpha is unique is to prove that the function is increasing. Okay, to do that we can use f of x minus f of y, and we compute that assuming that x bigger than y. Let's say f of a minus f of b. Okay, and a is bigger than b, and to prove that this is bigger than 0. But this one requires some work. We can do it. Yes, we can do it. We can prove that f of a is bigger than f of b, given that a is bigger than b. Try to do it. But we have another option here. We can use the derivative. So f prime of x is going to be 2x minus 1 over 2 square root of x plus 2. We are in this interval 1, 2. So that's our main goal. Okay, so we want to prove that this one is bigger than 0. Okay, so we can write this one as f of x is 4x square root of x plus 2 minus 1 over 2 square root of x plus 2. So we want to prove this one is bigger than 0. This one is bigger than 0 because we are in this interval. Okay, but this difference we don't know. So we have to show that's bigger than 0. To do that, okay, we know that x is between 1 and 2. So here, use another color. So x is between 1 and 2. Okay, so x plus 2 is going to be between 3 and 4. Okay, and the square root of x plus 2 is going to be between 2 and square root of 3. Okay, and once I multiply, I'm going to get 4 square root of 3. Okay, square root of, let's see here, it's going to be 4 square root of 3 less than 4 square root of x plus 2 is less than 8, because I had to multiply by 4. Now I need to multiply by x. So multiplying by x, or x is between, x is between 1 and 2. So when I multiply this one, I get 4 square root of 3 is less than 4x square root of x plus 2 less than 8. So now I need to subtract 1. Square root of 4 square root of 3 minus 1 is less than 4 square root of x plus 2 minus 1 is less than 7. Okay, so this one is always bigger than 0 in all cases. Okay, so it's bigger than this one, that's bigger than 0. That means it's bigger than 0 because this one is bigger than 0. And therefore, f prime of x is bigger than 0 on this interval 1, 2. Therefore, it's increasing. So we see it here, the function is increasing. Therefore, it's not going to go and decrease and come back to another number, another value. That's the one that we are scared of. But since it's increasing, it's not going to come back. And this is the only point where it hits the x-axis. This proves that we have a solution, but we added one more thing. We showed that this solution is unique on this interval 1, 2. And this ends our video. Thank you.